Morning, myself Prabhat J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is coefficient quantization error from the unit 4 finite Bernoulli defect in DSP. Let I discuss. Yeah. Quantization coefficient error is also known as coefficient quantization error is a specific type of quantization error that occur in digital signal processing. When filter coefficient or other numerical parameters are represented with limited precision, this type of error can significantly affect the performance and accuracy of digital DSP systems, particularly in applications like digital filtering, where precise coefficient are crucial for maintaining the desired frequency response. In the realization of FIR and IR filter in hardware or in software, the accuracy with which filter coefficient can be specified in limited by the word length of the register used to store the coefficient. Usually, the filter coefficient are quantized to the word size of the register used to store them either by truncation or rounding. The location of poles zeros of the digital filters directly depends on the value of filter coefficient. The quantization of the filter coefficient will modify the value of poles and zeros, and so the location of the poles and zeros will be shifted of the desired location. This will create deviation in frequency response of the system. Hence, we obtain a filter having frequency response that is different from the frequency response of the filter with unquantized coefficient. Okay. When the coefficient are represented using finite number of bits, the exact value must be approximated. The approximation introduces errors. The process of rounding and truncation, converting the precise coefficient value to their quantized version, typically involves rounding or truncation, both of which can introduce error. Also, in fixed point system, the limited number of bits for fractional parts can lead to significant quantization errors, especially for coefficient with small magnitudes. Okay, small magnitude. Impact of quantization coefficient error is frequency response alteration, stability, also noise. Quantization coefficient can introduce additional noise into the system, degrading the overall signal quality. Okay. Quantization coefficient error is an important consideration in the design and implementation of digital filter and other DSP systems. By understanding its causes, impact, and mitigation techniques, engineers can design more robust and accurate systems, ensuring that the performance of digital filters and other DSP components remains close to their intent design despite the limitation of finite precision representation. Also, uh, uh, for analyzing quantization error, error sensitivity is an important. Different coefficient in a filter can have varying sensitivity to quantization. Typically, coefficient with higher magnitude and those near poles of transfer function are more sensitive. Pole and zero analysis. In a recursive filter, quantization can move poles and zeros of the transfer functions, affecting the filter stability and frequency response. Monte Carlo simulation. Running simulation with random variation in coefficient can help analyze the impact of quantization and errors on system performance, and mitigation techniques of quantization of filter coefficient, which may first one is increase bit depth. Using more bit for coefficient representation can reduce quantization error, though this increase computational and memory requirement. And second thing is coefficient scaling. Properly scaling coefficients before quantization can minimize error. For example, scaling coefficient to a range where quantization errors have minimal impact, and then appropriately scaling the output. Optimal quantization, using algorithm to find the optimal quantization level for coefficient, minimizing the overall quantization error. And thing is floating point representation in system where precision in critical. Using floating point representation for coefficient can significantly reduce quantization error. Okay. If you have any doubt in this topic, you can comment me through. You can ask me through the comment. Okay. 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 We will meet in next video. Thank you.